I think we're working with building for a online hack. So this is for the Quen hack that's posted on DevPost. So we're just gonna put the DevPost. Alright, so we see the global AI hack with Quen Cloud, which is related to Alibaba Cloud. So we've chosen the memory agents. So build an agent with persistent memory that autonomously accumulates experience, remembers user preferences, and makes increasingly accurate decisions across multi-turn cross-session interactions. So participants should focus on efficient memory storage excuse me, and retrieval, timely forgetting of outdated information, and recalling critical memories within limited context windows. So our thinking around this was to create a brain-like process that would remember things or act, similar to how the brain works, just as a human would remember, etc., etc. So, there are methods out there that can do similar, but we were trying to build a specific type of system. So it's going to, or rather, it's supposed to behave like the brain. And instead of rebuilding the system from scratch, because gradient descent and stuff do work, we're just building on an extra part of a system that is sort of a valuation system. So it would score the risk associated with a experience or decision, how novel it is, what consequences are there, if there's uncertainty, how rare the occurrence of experience is, and of course just throwing in some human feedback. So what happens from my chat and conversation with AI, what happens with the human brain is that during sleep, it replays some of the experiences of the day, and that in turn makes that path of related concepts stronger. As they say, neurons that fire together wire together. And I think mood either increases or decreases learning rates. Human review is always necessary to stabilize what the model is doing. Something is only committed to long-term storage based on whether we need to remember it or if it's just something we're perceiving in the moment. And yes, we need to either forget or retain that bit of information. So this is where we're going with this, and so as it's describing, most agent architectures today look like this. So there's a conversation, everything's embedded, there's a vector database which is search and store, and then there's some similarity search that happens again, and so it learns from previous examples. However, we're going to do it a little differently. So instead of just saying memory is embedding, we're saying that memory has embedding, but it's also scored for importance. Emotion is classified. Is there novelty to this? How frequently has this happened? When was this memory last accessed? How confident we are in the memory? Is there a valid source for this? And we spoke about a graph network before, so relationships would also be kind of stored. So then the rest of the chat sort of just draws parallel between these concepts and what happens in the human brain. And I think, to simplify it, this is the type of NeuroGraph memory that we will be implementing. So it starts with an experience, and then the memory is obviously encoded, and embedding takes place. There is an importance score, there is confidence, novelty, emotion scored. There is a knowledge graph, as described. Whether that goes to long-term storage or not is decided. Replay and consolidation, forgetting engine, and retrieval engine, which then talks to the LLM. So, and then it goes on to make suggestions about how, to strengthen or, forget a memory. And yeah, there's and then there's obviously the proposed structure, but for working with it for now, I'm going to ask it to describe what needs to happen at each stage. And this is from the flow you see on screen. I copy and pasted that to the chat, and let's see. Okay, so it's still generating. So this is, well, phase one, we would need an experience, so we're just going to copy and paste this. Okay, you know what, let's give it a heading as well. Okay, we're going to define a variable there. Okay, that doesn't exist, so we're going to run that. Okay, so memory would then capture raw interaction, assign unique ID, timestamp it, store the raw transcript. So it's aligning it to the sensory cortex. So we're going to add that to our notebook. Okay. Okay, so I think we have something now. So its responsibilities are stated. So let's move on to stage 2, which is the memory encoder. Just gonna add some text there. I'll just copy and paste, and alright, let's see what's happening now. Okay, let's got some more text. So, okay, we'll copy that and we're going to paste it here. So facts, subject user, likes, object veneer, preferences for total, preference for void. So we're basically structuring, the facts, preferences of the entities, and intent. So we're going to have to find a way to encode every memory as such. Perhaps we can use an engine at this stage, but let's maybe call this memory 1. Right, and okay, so some additional knowledge here. Let me give context to the task. So text. Oops. Okay, so NER, entity recognition, trying to detect intent, extract preference, extract the facts, sum up the convo, and relationship extraction, obviously between entities, and then inform our knowledge graph. Okay, let's move on to whatever we're putting now, stage 3. So we're just going through every step and stage before we get into some actual vibe coding. Alright. Text blocker there. Okay. Oops. I think that should go within a text block. Okay. And we have another text block. Someone needs to tell me there's a library for converting everything to Markdown. I recall a project I was doing in one of the previous companies where everything needed to be Markdown, and I was having to hand compact that, which was less than optimal and a waste of my time because we could be doing much better things with the time. Anywho, perhaps there is one, and I'm just not aware of it. So if you know of one, then yeah, do let me know. So let's paste the examples of all this. Okay, and the one, thank you. And yeah, I should bring that forward. This doesn't work very well, but okay, that looks cute. Yeah, and we're just finishing off stage 4. I'm pretty sure if I just update and pasted everything here, I would probably be formatted already. Anywho, on we go with stage 5. Okay. Oopsie. Okay, let's go forward to that. Silly. Yes, if I have to forward that code. Anyway. And here we go with novelty. Computers are really today, yes. There we go. Okay. So, create another text block. Oh, yeah. Oops. Z. Right. Ah, I see. Never mind. Okay, let's go do that. Back to manual formatting, I guess. I could have just asked for the output to be a Markdown, but it is what it is, and we're working with what we have. Alright, and on to stage 7. So emotion, which would usually use like a sentiment analysis, or similar as being suggested. Yeah, okay, so let's go and see what do we have here. Okay, let's make sure that's bold. Rather, set as a heading, let's change that. Responsibilities. And finally, we arrive at the knowledge graph, relating different entities in the chain. Responsibilities. Subpoints. Right. Now, finally, stage 9, which we arrive at a long-term store. And so, yeah, I may be appearing to vibe for this part, but the idea itself is my own, which I use AI to flesh out. Right, so we're at stage 10, and then I think we can start deciding how to implement this with code. Okay, responsibilities, that, here. Okay, point. Right, and here's adaptive consolidation. So, has it been recalled? Is it human decisions? Yeah, so let's just throw in this part for fun. Text. Good. And then forgetting engine and a retrieval engine, which would be used to retrieve memories when necessary. So essentially a better version of RAG, I guess, but a very humanized way of remembering, if you could call it remembering. But like they say, the proof is in the pudding. So I'm keen to see if this actually does bring results. So I think it's a come back and watch that video when it is available kind of thing. So, okay. We're almost done with this conceptual part, we call it. Essentially, all of these videos are just me copying and pasting from chats where I've shared my ideas. I obviously had to flesh them out with some guidance from a place of being able to write, which is probably not anyone around me, but perhaps the AI would give me guidance. And then let's go into stage 13. So this is going to be a project, so I will baseline idea code kind of thing that I prepare as my page using also a data professional. We work together on this project. Gives it a second look, yeah, and we work together. He brings in, obviously, more expertise when it comes to deployment. However, I am still involved, and we work together to get things done. Okay, with our little knowledge graph, or rather, adoption graph. And okay. Yeah, so I think we've got the basics of what's going on. So this would be simulated or made up for now, but we can start to structure the. So in this case, I think the most beneficial piece of code would be. Okay, so. Okay, right, so input would be put. Okay, so I just want to turn this to a string so that Okay, so we're going to run our code here to test out what kind of response we get. So we've done most basic call, and there we go. So we have our dictionary, which is very similar. So just making sure that it also just knows the structure. Well, right, there we go, it's working. So now let's move on to embedding. Okay, so it's going to be some instructions to follow, which we're going to do. So at this point, perhaps it is. I wonder if it is with. So maybe let's embed these summaries. Let's call this some. Some hello pictures. Let's see what Pixon looks like. Great. Very well. Right, so we're going to call this Benny. Not Benny, but Fania. Okay, let's run that. Right, now we're going to follow the following instructions. So we need to do a pip install here. Not yet. Okay, well that's happening. Let's go copy the expected code. That may take a while, as we always do. Okay, run the model and create a new Benny. So next is now going to equal to Benny. Okay, so we defined Benny earlier. Okay, let's run that. It's taking a bit of time. We also have an OpenAI embeddings option. So, okay, this sounds valid. What is this? It's not that right. And we could do this. However, let's also try. I'll try something here. Probably spelled it wrong. Okay, ending. Right. Maybe we did this. Say. So we're going to replace that with some bare code. Why not? And then copy that. Why not again? And finally store everything as a memory. And now we've actually killed it with a one stone. So let's go and run this. Right. So here we go. Right. So now we've also done embedding there, but this is also an option. I'm just going to leave it in Notebook. So I'm just going to comment out. So that when British sees this, he's not confused as to why it appears here. Right, so what do we have next in what is called? simple code again. Right. So again, another part. Okay, so we're going to go again. So that code with there. Right, so let's give it a very explicit instruction. Give only, let's give it a task. You are a human being. Okay, let's say you are a human expert. Evaluate the provided memory item. You are required to score the memory out of 10. Consider the following. If something is a user, if a common personal fact, score very high. If a safety issue, score max. If a ounce of no value conversation, score low. And if repeated topic, score this process is aimed at estimating long-term usefulness, decide the play frequency, and influencing forgetting threshold. Improve my prompt. Okay, so it comes out of this. What stage are we at? Okay. Okay, so that. Okay. Include. So we need to include a function that okay, so we just want to do a little blob of code here. Okay, it's taking a bit of a while. Okay, so we should be good now. Alright, okay, so it's breaking it down into different steps, of course. Right, let's go back to confidence. Any confidence in us? Right, let's go for novelty. Okay, my bad. Appears to be a mathematical problem according to it. Oh, okay, so it's looking at the similarities. Okay, so it's looking at what is already existent, so my bad on that. We're assuming it was a new scoring. So, and then, right, so it's wanting to combine beta and bits. Not sure why, but beta is more explainable, hence that would be my choice of tool generally. However, let's perhaps explore the root of what is being suggested, and then, okay, so, yep, that. Right, so obviously, okay, it needs to be combined. Let's add maybe a text. Alright, so a knowledge graph, connect memories, so then here, I'm saying storage. You know what, I think I'm gonna pause for now and we will revisit this in another video. Thanks so much for watching and tuning in and watching me color up. Myself, Shraddha Nirvad, out for now.